Okay, let's share this. All right, looks like we're live. I'm going to post these links to the Twitter account and the Telegram channel.
Okay. Oh, I can get the link here too. I'm just going to send it to somebody else.
Okay, just checking the pre-meeting checklist. We'll get this meeting started shortly. Yeah, okay, I think we're about ready to start. Okay, welcome everybody on YouTube and anybody who watches this later. This is the second meeting for the Technical Steering Committee for the Permissionless Software Foundation. I am going to share my screen and share the agenda. There we go. So the agenda can be found, as always, in our GitHub Permissionless Software Foundation group under TSC for Technical Steering Committee. They're saved as an issue. This is all, we're following the model that was pioneered by the Node.js Foundation. So that's where this comes from. We meet every couple weeks. And so this is the agenda. I'm going to present a few of these bullet items with the PSF core, and Joey and David, feel free to interrupt me if you guys have anything to add as I go through these items. We'll get to a discussion around uptime monitoring and transaction history by address that Joey requested to add to the agenda. So we'll talk about that. And then we'll wrap up with a brief party or a brief summary of the Coin Party Hackathon. Three of the projects that really caught my eye that I think have impacts towards the mission of the Permissionless Software Foundation, and something that I think the membership should keep their eye on.
So, Chris, I would just add that we would maybe want to do a round robin introductions.
Sure, that's a good idea for people who aren't familiar with us. I'll start. My name's Chris Troutner. I founded the Permissionless Software Foundation as well as FullStack.cash, which makes developer tools for developers, particularly JavaScript developers who want to build on top of the Bitcoin Cash and BCHA blockchains. And so it's a wide range of tools. David, do you want to give an introduction?
Sure. I've jumped on board with Chris to help out with the Permissionless Software Foundation, something I believe in, and wanted to help out where I could, so I'm doing business development for him, or for the foundation. Thanks.
And I'm Joey King. I'm a full stack developer with Bitcoin ABC.
Right on. Thanks, guys. So just to introduce sort of the high level concept before we get into the nitty gritty, this is not, we don't have an official roadmap yet. This is just a proposed roadmap, and that's what we're operating off of right now. And you can find this on the PSF blog at psfoundation.cash. Go to the blog area, and this particular article is called Towards a Roadmap. And so the first couple items in the agenda speak to the column on the left called PSF Core, which is comprised of the BCH API REST API, BCH.js JavaScript library, and then the Gatsby IPFS web wallet, which is the sort of core front-end engine for building web apps and phone apps that can interact with the blockchain. And so these technical meetings are going to cover technical changes and things that concern people using these core tools. Eventually, as we gain more community members and we gain momentum, I hope that we'll be able to spend more time talking about these other three columns as we grow towards our goals of free speech, censorship resistance, and economic action. So our first couple agenda items concern that PSF core. There's been some updates recently to BCHJS. The token UTXO details is it's a call that sort of, if you have a UTXO, which is the thing that you actually spend in Bitcoin, what you need to do is sort of take that raw UTXO data and hydrate it with token information, so that you know if a UTXO represents a token or if it's just a normal Bitcoin UTXO. And so this token UTXO details call is the main call that does that hydrating property. And it now returns a string, and this is due to a change that Joey recently submitted, and it mostly concerns tokens with large decimal precision. Uh, those were getting burned, and there was these rounding errors in JavaScript the way it was being done prior. And now it uses the big number library, and it returns the value as a string because that's the most accurate way to represent a number with large decimal precision. Did I capture that, Joey? Is there anything you want to add to that point?
Yeah, just unfortunately in JavaScript. I mean, since this is primarily a web tool library, and a lot of app developers are going to be working with JavaScript, um, even if the API is returning good information in number form, it'd be very easy for developers to start screwing with those numbers if they're not using the right library. So by keeping it in a string, uh, it's not without its own issues, because if a developer just takes it and pretends it's a number, they're going to face the same problems. So it still is important that developers use the big number JS functionality when they're working with it. Um, Apart from documentation, it's just kind of one of those things that comes with the territory.
Right. Yeah, that's something I've struggled with. I mean, obviously, I need to update the API documentation to reflect this, but other than these videos and the API documentation, I don't know of a good way to communicate this type of nuance. So hopefully that's something that will just get solved as we move forward.
Yeah, I mean, ultimately, all we can do is make sure that the API is not returning bad information. So if the API is returning strings and the strings are accurate and the strings will never have rounding errors, it's up to developers to then take that information and not corrupt it.
Right. Right. So the next item is the BCH API. This is another awesome pull request that Joey submitted, which the rate limits were hard coded, and Joey submitted a PR to bring those out and make them configurable at runtime using environment variables. And let me just pull that up and show where that exists. So in the Permissionless Software Foundation GitHub repo, BCH API, there is a config folder, and in that is an index.js file. And here is where the environment variables get overwritten. So the way JavaScript developers will be familiar with this format, where it basically checks to see if this environment variable exists. If it does, or if it does not exist, it will use the default value that's defined here. And if it does exist, it'll overwrite that value with the environment variable. So anyone who runs an instance of BCH API, the REST API, you can set the rate limit for anonymous users, which is 50. So it's 1,000 divided by this number. So this works out to be 20 requests per minute. 1,000 divided by 50 is 20. And then the whitelist rate limit are people who authenticate with a JOT token. And in the case of fullstack.cash, there's the process for getting a JOT token, and then the rate limits increase to 100 requests per minute. So 1,000 divided by 10 is 100. And then this new environment variable here are whitelist domains. So if you have a specific domain that you want to apply high rate limits towards, like in my case with fullstack.cache, it's anything coming from the fullstack.cache domain or the PS foundation.cache domain. I want those to be in my whitelist. I don't want to restrict any API access to anybody using an app like wallet.fullstack.cache or message.fullstack.cache. So you can add domains to this list, and they will automatically get the premium rate limits applied to them. So that's this bullet point right here. Is there anything else you wanted to add to that, Joey?
Just kind of the same theme. You know, eventually we'll need to get that stuff documented as well. I mean, right now it's not that big of a deal because if somebody's using it and they just don't do anything about those variables, the app uses the same defaults that it used to use in the past. So it's really only something that a more sophisticated user who's trying to mess with something needs to worry about. But just some kind of weird JavaScript things, like for example, if you want to do your custom list of whitelist domains, that environment variable doesn't look like an array with 2 strings in it. It's just a long string of text with a comma, and you need just the domains, not so. It's the kind of thing that, like, if you're used to running backend Node apps as a full stack developer, like you'll get it, and you don't need documentation for it. But if you're just pulling this down and you want to run it, and you're like, oh, I'd like to add some domains, you're probably going to run into that issue. So, not really a new thing, but just the same theme that we'll need some kind of a reference for the stuff going forward.
Right. Okay, so I'll give a quick update on the SLP Bridge project. For people who are unfamiliar with that, there is a blog post article called Cross-Chain SLP. This is a project that has been funded by Don Juan, who works for Alva Labs on the Avalanche chain, and he is funding a. Let me see if there's.
Just clarification, it's Don Wonton, not Don Juan.
Oh, I'm sorry. Thanks for catching that, David. Yeah, so he's funding it, and we've identified a developer in Venezuela who is going to be doing the actual work. And he's already been working for a week on this. And just in the 1 week, he's managed to create a library. It's called SLP AVAX Bridge. It's in the PSF GitHub repo. And so far, that library can mint new SLP tokens and burn SLP tokens, which are the 2 primary functions on the Bitcoin Cash side. And now he's working towards setting up an Avalanche full node, and then he will create tokens on the Avalanche side and create a library that does the same thing on the Avalanche side, burning tokens and minting tokens. And so once that basic functionality is in place, we will be able to do asset transfers across chains. So the app will have an address on both chains. You'll send SLP tokens to one address where the app will burn them and then mint them on the other chain, and then send them to the desired address that you specified. There'll be a web interface for this. So already great progress on this, and I'm excited to see along for the ride with this. I'm going to be also building a similar bridge between BCH and BCHA. So at the end of this project, we'll be able to transfer an SLP token across all 3 blockchains. So big shout out to Don Wonton for funding that project. It's progressing very well. Okay, next item on the agenda is SLPDB, which is the indexer that controls the use of SLP tokens. It's recently, James Cramer's recently released a new version that's optimized to work with NFT tokens, non-fungible tokens. There was a problem that was discovered a few weeks ago by Sweet.io. They are a phone app that is making non-fungible tokens on the Bitcoin Cash blockchain, and they're producing large quantities of them. And it was through that process that we all collectively discovered that SLPDB you is does not process NFTs the same way. It wasn't optimized in the same way. It used a lot of memory, and it caused the majority, if not all, of the SLPDB instances around the world to essentially stop working. They stalled out at specific block heights. And so James has addressed that. He's released a new version. I've stood this new version up at fullstack.cash for both BCH, BCHA, and testnet, and it is running great. And haven't really had a chance to do any sort of benchmark testing with it, but it did sync from Genesis, and seems to be running fine. And I've updated the Docker SLPDB GitHub repo, which is part of our PSF core, to use this new version. And I will be releasing database snapshots soon. Actually, that's another point that didn't make it on the agenda that I should speak to. So for people who want to use the PSF core, one of the main ways to stand up your own infrastructure very quickly is fullstack.cash/cash strap. So cash strap is a play on the word bootstrap. So this is how you bootstrap your infrastructure. And we've got links to these Docker containers for that are part of PSF core, and we also have links to pre-synced databases so that you don't have to sync from Genesis, which is a very week-long process. And I am currently working with Andrew Hill, the CEO of Textile.io, who is working with Filecoin. So right now, these database snapshots are distributed over Tor, and very soon they will be uploaded to Filecoin, and we will have a download interface for pulling these database snapshots up down from Filecoin. And so the cost of doing this is going to be cheaper for the PSF because we pay these infrastructure costs, and it's also going to be faster, and it's going to allow us to update the snapshots more often. So this will be a pretty significant upgrade once we get it going. Plus, we get the opportunity to be at the forefront of Filecoin as the technology progresses. Okay, so with that, let's move into the discussion of uptime monitoring. So Joey's been setting up sort of a mirror image of the PSF core on the Bitcoin ABC side for their own usages. And so that's why he's been making so many valuable contributions to our code base. And let me introduce the build verification test system, which is what I built to monitor the infrastructure at fullstack.cash. I initially started building so the build verification test system I'll refer to as the BVT. I've built these for several companies over the last few years. This is probably like the fourth BVT I've built, and people can see the output of it at metrics.fullstack.cash. What this is it's a brief at a glance summary of the health of all the infrastructure running at fullstack.cash. So it does these liveness tests. It checks the full node, it checks the Fulcrum index server, it checks the SLPDB, and it does that for mainnet, for BCH, ABC, and testnet. And like you can see right here, it's sending me a warning, hey, the SLPDB on testnet has fallen behind. These all say okay, which means the test's passed. It runs it runs liveness tests, unit tests, integration tests, and end-to-end tests. And it does it every 2 hours. It basically tests everything that is possible to test, and then gives a status update. If these things said failed, then I could go up here to these links up here and click on them to drill down into the logs and find out precisely which tests failed. And so this is available. This is also open source. And this link here will take you to that repository. I haven't done a very good job documenting this because so far it's been a tool for me. But I'm definitely interested in better documenting it and collaborating on the code with other people if it's valuable to other people. Joey, what obstacles have you had in terms of uptime monitoring, and what features are you looking for?
Yeah. So I mean, a system like that I think is a great start. But in terms of what's needed, especially like I know at ABC, we're operating a wallet backend, so we need to have some sort of idea if the backend has degraded performance or is down. And I guess features for that are one, kind of immediate notification if say SLPDP isn't synced anymore, um, or if some other component's off, or like a test has started failing, or there's some reason to believe that the API is down. And the second thing would just be logging of that, so we'll have some sort of reliable information in terms of like, hey, our uptime is 98.3%, or like we'll have a way to measure that so we can focus on improving it.
Yeah.
And as far as the percent uptime, right, like that's the BCH API metric that would be helpful in terms of measuring how the software is improving over time.
Yeah, I'm curious to hear what solutions you come up to for that problem, because I too want to monitor uptime. It's not so much, the problem doesn't lie so much in the actual monitoring, but in the reporting.
Right.
And I mean, we could just put the numbers in a database. That would be the conventional way to do it. I've thought about using the Bitcoin files protocol to actually write like a small JSON blob to the blockchain. Uh, it's not necessary, but it would be cool. Uh,
I get how it's cool, but yeah, I like that. If the problem is that people think we're misreporting our uptime, maybe, uh, and I guess that could be a problem for some operators. But the way the incentives align up, it's like if you're running this software, it's because you want higher uptime and you want to improve it. So I don't see it as such a big risk, but I get how it'd be neat. Yeah, that's
yeah. What are we doing if we can't have a little fun? Okay, so yeah, so that's the system that I've got in place. Joey's going to explore what's most appropriate for his business, and like I said, I'm happy to accept pull requests and collaborate. And if there's continual interest, I'll make a bigger effort to better document the system that I've built. Next item on the agenda is transaction history by address with parsable information. Now, Joey, you and I have had a brief discussion about this, but can you just sort of introduce this, like what you're looking for specifically?
sure. Like if you're using this backend to power something like a wallet, there's pretty specific and standardized information that you need to get about each transaction. And right now, there's a very basic transaction history endpoint that just returns a list of TX IDs and block height. And that's a start. But it means as an app developer, you'd have to call that endpoint. Then you'd have to organize those TX IDs somehow by whatever your wallet's using. Then you have to get more information for each TX ID. Unfortunately, the amount of information you need for each TX ID is kind of a lot and not straightforwardly organized right now in BCH API. So some things you would need to know is, hey, is this a BCH transaction or is this a token transaction? Is one.
Mm.
And if it's a token transaction, then there's a whole other endpoint you have to hit to figure out what kind of token transaction it is. And if it's a cash transaction, there is a details endpoint you can hit, but that's missing some information about what the inputs were. And if you don't have that input information, you then have to make another, at this point, kind of recursive API request on the information you do have about the info UTXOs. So it means it's possible for an app developer right now to get this transaction history, but it's a pretty standard thing that an app developer or user of BCH API would want to do. And it's not great that they have kind of this significant and undocumented end-around burden to get everything to work right. So the information's in the back end. It takes some work to get an endpoint together that will then give app developers something like, get history for address or an array of addresses, and just return everything organized with like, this is an incoming BCH transaction, or like this is an outgoing token transaction. This token ID, this quantity was sent from here to here. And that's the kind of information that users are used to seeing when they pull up transaction history in their wallet, right? They don't see, oh, well, UTXO index 1 from address Y went, like, they don't need that. They just need to say, oh, somebody sent me some money or I sent some money, and that's it. So right now, it's just, the information is there. It's going to take some dev work to organize it. And I think that should be done at the API level, since I think it's a common enough use case.
Yeah, and at the API level, let's take a minute talking about this, because this speaks to a trade-off that I'm constantly wrestling with, and that we wrestled with also when we were both at Bitcoin.com. There's this question of, where do you put the load on the client side or on the server side? So for instance, one way that I've dealt with this, or have made the same trade-off, is with the hydrate UTXO method, which is an endpoint on BCH API. And all it really does is wrap the token UTXO details endpoint on BCH.js. And where the trade-off comes in is, when I was building wallet.fullstack.cache, which uses the same type of architecture as mint.bitcoin.com, as Badger Wallet, uh, the 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 client side app, in order to hydrate those UTXOs and figure out which ones belong to tokens and which ones are normal Bitcoin Cash UTXOs, it was having to make an excessive number of API calls. And the business model with fullstack.cache is that we essentially rate limit API calls, or that's essentially how we make money. Like, we want more API calls, but we also, you need to pay for them, and you can only have so much of that resource. And so one of the things you have to do in order to get a good user experience is to reduce the number of API calls. And so token UTXO details was just making a ton of API calls, and by wrapping them in that hydrate UTXO endpoint, we let the server do the heavy lifting. So the server behind the scenes is making all those API calls, so that the wallet on the front end just has to make one API call. And that's much, much better from the user experience standpoint. But it also makes that endpoint like much more expensive than the more fundamental primitive endpoints, in that it's doing much more when you call it. So it at scale, it puts the load on the server, and so that means, like, at scale, that you have to have bigger servers. And versus if you kept it at the client side, that makes a worse user experience, but every user is treated fairly for the resources that they're consuming. And so that's where it's a trade-off. And so I see your point, and I could definitely see the advantage in creating an endpoint on BCH API that's just like, give me the address of the sender of this transaction. That's the question we want to ask the server. And then the server can make all those calls, which it's more efficient at, but it's going to impact the ability to scale the server. And so I don't totally know what the right answer is. I mean, I think it's particularly in the short term and at low scale, the answer is clearly put the load on the server, improve the user experience. But at scale, that decision is going to come back to bite us.
Yeah, I think it just needs to be, it's a resource pricing problem, right? Like, it's a more expensive computationally API endpoint. And from the perspective of PSF, it means maybe it needs to have a certain different point usage, or its consumption needs to be measured a little bit differently. But from the app developer's perspective, like, they're going to have to make API calls to get those anyway, right? So, I mean, you can make it cost just as much as all the other weird recursive calls they would have to take. but it's still the same information they want, and it's still the information in like a certain standardized capacity. So ultimately, like I don't think there's anything wrong with rate limits. Like from an app developer perspective, you want to limit your API calls anyway, and you're trying to make the app more efficient. Something like transaction history, like at least when CacheTab adds that, because server costs are expensive, whether there's rate limits or not, right? Like you don't want to just be hitting it with everything all the time. It would be to store a lot of the transaction history in the database, right? Like past transaction history is not going to change. And just because it's in the blockchain doesn't mean we need to do an API hit to the blockchain every single time for a transaction that happened like a year ago. So I think developers are still incentivized to minimize that consumption. And it's mostly kind of a pricing problem from what kind of rate limit does the server want to take for a computationally more expensive hit. But from the user perspective, if that's not going to be supported, then it's just another documentation problem, right? Like if there's an open source, like, hey, this is the information you need, and depending on how your app works, you can make all of these calls or just some of these calls or this other call, like that's fine. But the way it is right now, like every app developer is going to come up with sort of their own Rube Goldberg machine for how to get that information.
Right.
And while that might help, like if you have very easily codified rate limits for everything else, I don't think it really encourages as much innovation as we could. Like app developers, some of these things they should just have the resource for. So you're like, right, that's how that piece of the wall is going to work. I get the transaction history, I'll build the rest of it. So I think it's more of a resource pricing problem, I guess, is the summary.
Yeah, that's a good point. And you also pointed out something that was, I kind of was talking about the trade-offs, and then you pointed out, well, there's a third option that at scale, if this is really a valuable thing, like it could almost essentially have its own indexer, be its own REST API just for transaction history, and that would lower the computational cost. So that's something to keep in mind as well. But yeah, I like the way you put it. It really is just a resource cost problem. And right now, the resource is pretty cheap. And it's just one of those things. It's not really a problem unless it's like a champagne problem.
Well, it's not super cheap, right? Like I'm running some of these servers too. Like it sounds cheap-ish. It's cheap compared to like, I don't know, running a mine or something like that, but it's not free.
Right.
And
Well, and the rate limits are essential. That was where I think we went horribly wrong with developer.bitcoin.com, was that we didn't take rate limits too seriously soon enough, and a lot of our downtime issues were just due to abuse. Just because we didn't have the rate limits, people took everything they could take. And so when I started building the PSF core, those rate limits were like number one thing that I built. And I was pretty gun shy to open up. Like I don't know, when I first started it, the anonymous rate limit was like 3 per minute. I mean, it was super conservative because I had all these PTSD from the rate limit abuse at Bitcoin.com. So it's taken me a while to get brave enough to increase the free tier up to 20 per minute.
Right. Yeah, no, it's an issue. So it's something that's never going to be done, right? Like server resource is scarce, and it changes over time, and you can make it more efficient with code improvements, but it's never not going to be scarce. So
yeah, like I said, the trade-off is you're always just moving the load around. You can't like not have the load. Okay, well, that's great. I think last thing on the agenda, I'll just give a brief review. So the Coin Party Hackathon just finished. I participated as a contestant. That was pretty fun. It's the first hackathon I've ever actually attended as a contestant. I've always either been a judge or a mentor or both. And that was a lot of fun. We built a game called geodrop.cash, and it's a map-based scavenger hunt, very similar to Pokemon Go, except instead of running around and collecting Pokemon, you the canonical use case is like a coffee shop that wants to promote their business by, say, dropping like free coffee tokens around their neighborhood. and this is, I think it's been one of the best received projects that were built in the hackathon. And I'll just leave this here. I'm going to put some more links in the about page to some of the videos that was published on how to play it and what went into making it. But it's a great example of some of the tools at fullstack.cash. We used the BCH wallet starter, which is a Gatsby starter. We figured out how to compile this into a native Android app, which works great. But real briefly, there's these explore, play, and coin drop, and you can click on these different buttons to zoom around and find different games around the world that people have built. You can use the cash drop page to create a campaign and drop your own tokens for people to find, and then hitting the play button will take you to the play screen, where it'll show you where you are, and it'll give you directions to the closest point to you. And when you get close enough, the collect button becomes enabled, and you get an SLP token, and you get 3,000 satoshis, which is enough to then like send that SLP token somewhere. So you don't have this problem where you get an SLP token and you can't move it. So that was GeoDrop. Another couple projects that I think are notable for the PSF community is SLP Ship, which was done by Anastasia, and I can't remember the name of the other two members, but they also placed well in the previous hackathon. What this is it's very similar to the SLP token bridge that we're building. They were able to take SLP tokens and represent them on the Ethereum chain as wrapped SLP, which is the rage right now for like moving BTC. You wrap it, and all these different blockchain assets can be ported over to Ethereum by wrapping them. So they took that same idea and they applied it to SLP tokens. So this is another way of porting SLP tokens to another blockchain. So very similar to what we're doing, but a different way of doing it. And the thing that struck me in particular by doing it this way is what I'm going to start referring to as the minting problem, where minting tokens on SLP is a fairly centralized thing right now. It's very hard to do multi-signature minting. I don't know anybody who's actually done that. And if we have the ability to move tokens across blockchains, then we can use the best features of any one blockchain. And so in Ethereum, you can do all sorts of sophisticated minting, whether it be multi-signature or totally automated with a contract. So how this applies to the PSF is theoretically, it would be possible to actually mint new tokens on the Ethereum chain or on the Avalanche chain, which runs the same code, using a smart contract that say, 5 out of 10, let's say we had 5 people on the ComCom and 5 people on the technical steering committee, and it would require 5 of 10 members to sign a message in order to bring new tokens into existence, so that no one party, can control that or shut that down. And then those newly minted tokens can then be brought across to whatever chain we need to use them on. So that was what really struck me with this project. And lastly, I'll speak real briefly to the uncensorable web. So the mission of the Permissionless Software Foundation is free speech, censorship resistant, and economic action. This really spoke to all 3 of them. They combined James Cramer's Bitcoin file protocol, which is a way of storing small amounts of data on chain, up to 10 kilobytes. And you can do more. That's a reflection of the 50 chain limit. And then what Shamari did, the guy who did this, he took James's idea and he created a new YAML metadata format. So YAML files are used in like Docker Compose. They're used in many different software projects to sort of describe at a very high level what the program is supposed to do. So in Docker Compose, you use this for composing several different Docker containers and get them all working together. And so he created a YAML format for describing a web page, the content of a web page, and where to find like the resources, so that just the data that is most at risk of censorship, like the actual content, that can be stored to the blockchain. And then the things that are not at risk of being censored, like the jQuery JavaScript library, like that's so ubiquitous, there's no reason to store that on the blockchain. That can be separately loaded from other sources. And so it was a very slight tweak, but very innovative. And I actually had a chance to talk to Amri about this idea a little bit. And because I'm concerned with this idea of on-chain data bloat, I'm seeing more and more market signals of people who want to do it, even given the constraints that exist today, which I think are fine, and I do not hope ever change. And he said there's nothing magical about putting data on the blockchain, because eventually, when we have 100 times more transaction volume than we do now, most infrastructure will probably run pruned nodes and pruned indexers, and this idea that the data on the blockchain is going to be there forever is going to go away. uh, and so at that point, there's nothing magical about putting data on the blockchain. I thought that was a really good point as well. um, which is why I'm so excited about the work I'm doing with Filecoin, because I think that is the place where the data should go long term. And so I'm just bringing it up here because this idea of uncensorable data is resonates with me and the mission of the PSF, and it's an innovative new twist, but it's not without its concerns. So if there's anybody technical watching this, I encourage you to check it out, and let's continue discussing this. Um, does that, do you guys have any comments on any of this? Anything of this inspire you?
I just wanted to quickly clarify that YAML actually stands for yet another meta level. Is that correct?
I don't know.
Ah,
You might be
I
right
think it's
about that.
yet another markup language.
markup language. Okay, thanks, Joey.
Of course it does. So yeah, anyways, that was worth mentioning. These hackathons don't come out along very often, and when they do, there's usually a few gems left behind. I thought these were that. Okay, well, I think we can wrap up this meeting. Is there anything you guys want to add before we wrap this up?
I just want to make a quick comment about the geodrop.cash. I had a chance to play with it while the hackathon was going on, and I thought it was pretty unique. It reminded me of the times in 2014, 2015, when similar things were attempted on the BTC blockchain. And of course, that's not as inexpensive to allow that to happen now. But yeah, it felt like old times. So I just wanted to put across my little smile for that one.
Right on.
Yeah, sounds good. Thanks for organizing. I think yeah, going forward, I'll try to scope out some features, maybe put some PRs in for the stuff I want to see, and documentation is just never done. So
Yeah, exactly. Thank you so much for your contributions, Joey. They've really helped improve the value of the PSF core software. I'm glad to be working together with you again.
Oh yeah,
Thanks, guys.
Yeah. Okay. So we'll have another technical steering meeting in 2 weeks, and this same time next week is the community committee meeting, where we're going to talk about funding of projects and the whole sort of PSF token economics and how we want that to work in the future.
sounds good.
Right on. Cheers, everybody.
Bye bye.